Hello. In this lab, we will be observing the phenomenon of a bar magnet traveling through a tube of aluminum foil, and how the current induced in the tube exerts a force on the magnet, causing it to slow down when falling through the tube. For this lab, there is calculating data by analyzing footage of the bar magnet falling through the tube, modeling the physics interaction computationally, and comparing the predictions of the model with the observed data. The physics principles involved are Faraday's law, which is used to calculate the induced current caused by the magnet, the Biot-Savart law, which calculates the force exerted by the falling magnet, and Newton's second and third laws, which are used to find the force exerted on the falling magnet by the whole system containing the tube and the earth. The lab goes about like this. Using the materials listed here, the bar magnet is dropped with the north end facing up into the vertically held tube so that it falls through the tube in between going in, so that the going in and out can be recorded. All of this is recorded on video by a smartphone, and so after 5 trials the footage is analyzed in order to eventually get the average time for how long the magnet is in the tube. The way I analyzed the footage was using the Tracker app and analyzing frame by frame in order to find the times. So, now here's some questions for clarification. Why can't we use a Ferris tube? Well, that would cause the magnet to be attracted to the sides and prevent it from falling. So what happens to the magnet? How does this compare to a magnet falling in free space without a tube? The magnet's fall is slowed down due to the magnetic forces, and in free space it would fall faster in the absence of these. So here's the data. Here's the width of the foil, the length of the tube, the inner radius of the tube, and here are my values for the time, giving this average time. And so now I'll show you the code for the model. As you can see, there are the constants used, and the graph of the velocities and time is set up, and here are the dimensions of the tube. And so here's seen the code for modeling the conductive tube as a state of non-interacting conductive rings. And so with the mass of the magnet and the moment found in MyLab 3, the magnetic field relative to position r is found. Then the rate of change in the magnetic flux through each ring, and so Faraday's law calculates the current, and then the Biot-Savart law calculates the force exerted on each ring, and Newton's third law calculates the force exerted by the magnet. So here's the net force and Newton's second law writing the position and velocity, which models the magnet's motion. And so here's the model. And as you can see, there are 2 colors shown on the tube. These represent the current flowing through the rings. So the blue is clockwise, while the red is counterclockwise. These are shown to be true using Faraday's law. And now, if the magnet flips with the poles being different, it still slows down, and according to the code, it doesn't change it much. The observed time was shorter than the model, and this could have been due to deformations in the foil, error of data reading, as well as the model being made up of rings. And as you can see with the way the graph is shown, this shows some error in my experiment, because there should be a moment in which the velocity is clearly constant for a bit, and that's the time in which it's through the tube. So this is due to the forces canceling out, causing a constant velocity, which is shown to be true by Newton's first law, and then the magnet stays at the constant speed until it goes out of the tube, and then that's when gravity starts acting and accelerating on it again. So here's to top off the lab with some discussion questions. What if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? So in this case, the conductivity would be higher as well as the current because of EMF over R. And so what if holes or slots were cut into the tube? How would this affect the ring's current in your model? Well, this would deactivate the effect the tube has on the magnets in these places where it's cut. And this is just due to the nature of the loops. And so that's it. Thank you.